She's while she's pulling up the screen, if we could have you drop your name and your connection to math in the chat, we'll love that just to kind of know who's in the room.
Okay. Can everybody see my screen now?
Yeah, we can see it.
Okay, great.
Welcome, welcome, welcome. All right. I think we're ready to go.
Okay, well, thanks for your responses and for joining us. My name is Cynthia Catro-Minnehan. I'm here at University of South Florida, and my colleagues are?
I'm Queshonda Kudaisi, and I am at the University of North Texas.
I'm Dr. Ruthmae Sears. So I'm pleased to present with Cindy and Queshonda on this presentation.
Great. Well, we would like to share our work exploring perspectives of our secondary mathematics teacher candidates as we infused technology into our secondary mathematics teacher preparation program. Let's see. So I think Dr. Sears, if you want to go ahead and give us a little background.
Yes, good morning, everyone. So as we think about technology, it's here. It's the reality in which we're working. We're arguing over ChatGPT. We're looking at artificial intelligence. We're considering different forms of coding. So the construct of mathematics, just simply being paper and pencil, is actually becoming more and more obsolete because we're using so many tools to help us construct mathematics, share information. Now, within this construct, the IST standards talk about this construct of students being learners, leaders, citizens, collaborators, designers, facilitators, and analysts with the technological tool. But we need to go further in thinking about the competencies that it's not just about ISD standards, but also really thinking about the world in which they're working with, because the challenge is learning where the pre-service teachers have this knowledge to support themselves, but also support other learning. And so that interplay of their role has to also be co-constructed as well. You want to go to the next slide, please? Mm-hmm. There has been other calls relative from the U.S. Department of Education, the Office of Technology, the use of technology as a tool to transform teaching and learning. But that has been from when you think about the 1989 comment where they said technology can be used to enhance and transform the mind. And so on many of the Hyde, Bloom and Hyde, their technology handbook, when they talked about, I think it was this construct. So they had many articles highlighting how technology can be used to be transformative in nature. And so when you think about how technology evolved from the fight with the scientific calculator in the 80s to now where we're at relative to animations and also this construct with 3D imagery, et cetera, it's going to change the way we're teaching, but also thinking about the evolution itself as to how far we've come, but also how far we will be going, because we start thinking about space, how we're going to take advantage of technology and preparing kids to teach for that era in which they may be living in space. And then U.S. Department of Education, the National Education Technology Plan, they've acknowledged that most states have adopted technology mandates for appropriate use of technology. And so as we think about this, the national calls are there, the statewide calls are there, but there are also standards being stated. Now within NCTM in 2011, so FYI, that's 12 years ago. And in the world of technology, even that is considered obsolete. And so when you think about how we've evolved so much, really thinking about how would we even enhance these standard documents, like this is strategic use of teaching technology in teaching and learning mathematics technology, and which promotes the integration of technology across mathematics teaching practices. And so as we think about the NCTM, this guideline provides a roadmap of the importance of it. Now, many of us have used various tools from Desmos, GeoGebra, Wolfram, Malfour, Mathematica. There are many tools out there that allows us NCTM resources, CPM, CPOMs. So this construct to support learning is evolved significantly. Now, within the state of Florida, we do have the Florida Best Standards for mathematics for K-12, but the Florida Best Mathematics Thinking and Reasoning Standards, they provide explicit practices that should be integrated across the K-12 setting. Particularly, one makes note of, apply math real world context. So in that case, you could actually pull real world data from the internet and other sources. Complete tasks with mathematical fluency. So there are many online resources. You could use Pearson, you could use iExcel, My Math Lab. There are actively participate in effortful learning, both individual and collectively. You can share your ideas using Jamboard or any group chat. I mean, these interfaces exist, demonstrate understanding by representing problems in multiple ways. So many students can actually create models and images and accurate figures using technological tools. And then use patterns to and structures to help understand and connect mathematical concept. So when you read these standards, many of these can actually be conveyed using technological tools. And so this reinforces our need for our students to be proficient and competent in this space. And so as we think about it, really thinking about how do we integrate it to promote mathematics, not just for the content standards, but also for the thinking and reasoning standards. And so as we move forward, really thinking about ways to support our students to use our tools effectively, but also purposefully to communicate and engage in mathematics teaching and learning.
Oh, awesome. Thank you so much, Dr. Sears. So the purpose, recognizing the importance of technology integration into mathematics teacher preparation, we wanted to know teacher candidates' perspectives about it. So we designed a study with the aim of discerning those perspectives and insights into the adoption of technology into their practice. We wanted to know what programmatic improvements we might make to better prepare teacher candidates to infuse technology into their mathematics teaching practices. So we surveyed 22 teacher candidates from across the secondary mathematics program using the George Mason University's survey on use of technology in mathematics. And we also included several open-ended questions. So why is this important? Well, teachers are considered key players in the effective integration of technology in teaching and learning. And by discovering these common patterns related to teacher candidate factors, these common patterns may influence the design of future teacher training and professional development programs for our program. So the technology acceptance model is considered one of the most effective models for explaining the acceptance of new technologies, and it has been examined and validated through various applications. So agreeing with this original TAM models, many studies confirmed that perceived usefulness and perceived ease of use both impact students' attitudes toward using technology. Students here being our teacher candidates, with perceived usefulness having a greater impact. So we used this framework to make sense of our teacher candidates' responses about their perspectives on using technology in their secondary math teacher preparation program. This model says that if a student perceive the technology as useful and easy to use, they are more likely to actually use it. So this was our research question. What are the common patterns related to teacher candidate perceptions of technology integration in a secondary mathematics teacher preparation program? And Dr. Kudaisi.
So to answer that research question, we cast a wide net. We collected data from teacher candidates in our teacher preparation program. And we were able to get 20 secondary mathematics teacher candidates enrolled in the mathematics education courses in the spring of 2022. And I believe that was like a technology course and several mathematics methods courses. And we used the George Mason survey on the use of technology in mathematics. And we also included a few, which included a few open responses. So if you could go to the next slide. And there is the survey that we used and gave to our participants. And so if you notice there's several questions that's being asked But generally, we ask participants to respond to quantitative and qualitative questions that asked about their perspectives on technology use, the potential benefits and drawbacks of using technology, and what they hope to learn about using technology in a course that would impact their future learning. And so we also added a few more questions just to get a little bit richer data. And so we asked more questions about support, comfortability, available resources, factors concerning tech use, features to look for, what constitutes good technology to the participants, and their beliefs on student-teacher roles in supporting learning. And so what we found was, you go to the next slide.
Okay, so the quantitative data. Our quantitative data revealed that teacher candidates were most concerned with knowing resources for integrating technology into their mathematics lessons, and also how to effectively use that technology in their mathematics lessons so to increase student learning and engagement. So teacher candidates were less concerned about their ability to use and demonstrate technology, which may speak to their digital nativeness. So that was an interesting finding. Dr. Kudaisi?
So after conducting quantitative analysis, we conducted qualitative analysis. And so after conducting thematic analysis, 5 major themes emerged from the data, which include accessibility, effective use, resources, student learning or engagement, and technical issues. And what's unique about 2 of them is that it aligned with the positive attitudes toward technology adoption, theoretical framework we mentioned earlier. And so that is the effective use theme, and then the student learning or engagement theme. So now we're going to take a look at each one of these themes and show evidence that support those themes. So the first theme, if you can go to the next slide, was that we'll discuss is effective use. And so that's just some of the excerpts directly from the data. And so one of the sub themes I would say we came to was technology as transformative. And so teacher candidates were wanting to use, they were wanting the technology to be effective in ways that were transformative, that were learner driven, and in ways that would empower their students to have agency. And then the next theme was student learning or engagement. So they wanted the technology to be used in ways that were creative, relatable, relevant, responsive, and in ways that promoted active learning. And so then our next theme.
Less evident, but still evident in the data, was the accessibility of the technology. And so some of those emergent themes that we saw in this area was technology as a barrier. It may not always be accessible, or students may have difficulty using the technology. So I think our teacher candidates are showing a sensitivity to equity in technology infused space, and technology as access. Students can use technology from anywhere. So an appreciation for the transformative effect of infusing technology into their mathematics teaching, and potentially learning as well. Another less evident theme was resources. Technology is a rich resource. Some of our teacher candidates spoke to the fact that the technology allows teachers to use technology within their math classrooms, and using a variety of resources, not just using one particular learning platform, for example. And the evidence that our teacher candidates are aware that there are free resources available, and knowing where to find those free resources was another theme that came out of the data. A third theme that was very interesting was the issue of the technical issues theme that we saw in our teacher candidate voices. Sometimes technology can be a little bit of a barrier. We all know that. We live in this space now, and we take it for almost for granted. But some of us, that is we run into problems. So this was reflected in our teacher candidate voices, that they are aware of the fact that when they infuse technology into their teaching and learning, they're going to have issues, and there could be technical difficulties, and that they need to have a backup. So technology not working, you always have to have a backup, some printed worksheets, for example. So those are the things that we saw arising from this data.
So if I could jump in, Cindy,
Yep.
and say a little bit about like when we were coding this originally, we had it all coded as accessibility, this theme and then the accessibility theme. But what we ended up seeing was accessibility was seen in like a positive light, and that like students could access it at home, you know, if they miss class, teachers could use it in ways that were supportive to student learning. But then the accessibility issue of like understanding how to use the technology is where we saw we needed to separate it. And so just addressing those issues that, you know, those technical issues happen. And then even more so like teachers or teacher candidates needing to be trained on that particular technology. So I wanted to highlight that.
Thank you so much. That was great. And then I'm going to hand it over to Dr. Sears to talk about the implications.
So given the perspectives of pre-service teachers on their use of technology, it highlights that teacher preparation programs has to reflect critically on highlighting to students the usefulness of the tool, but also how to use the tool. So if we continue to highlight how the technology is useful, then we're hitting the mark, and our pre-service teachers are more likely to adopt the technology. We have to continue to keep the focus on effective use and providing resources. Now, this is one of the challenges of technology evolving so quickly. As we think about our toolkit for success, we have to really think about what are the common tools, but also how we're proposing the tools being utilized. Are we limiting the constructs? Are we considering, you know, effective transformation, or really thinking about how do they engage with it? Is it an enhancement? Is it a transformation? Or is it simply a reinforcement of the learning? And so this construct of not just introducing tools and showcasing tools, but really helping students to conceptualize and visualize what is the purpose of the tool and how could it be used to enhance and transform mathematics. It's going to be critical in our practices, but also how do we engage it within our spaces. Now, at the University of South Florida, as the program coordinator for secondary mathematics undergraduate, I've actually made sure that every class have a technology assignment where they have to show competency, be it from developing a web page, creating a video, teaching with a technological tool, embedding it into a Canvas module as a part of their assessment of creating an online Canvas course. But it had to be intentional. And so this required us to do cross planning and cross conversation. And now we're even going further, come on Saturday. So Cindy and I would actually be working with the Prep and Me. It's a program where we're actually going to be working with our K-12 students and having our pre-service teach those students using an enrichment activity. So we're not just going to do a drill and practice, but really take a question, extend their concept of it, and think about how they could be applied in other settings, and reflect on how technology could help them, you know, unpack and support that learning opportunity. But this goes back to being intentional as to how do you plan to support technology integration across the space. Next slide, please. So in this regard, we kind of considered our context. How might these so our question to you is, how might these patterns that we're observing influence the design and training of teacher preparation programs or professional development initiatives? Because as I thought about the Florida Distance Learning Association, we've come a long way, you know, an era from when technology was like, you know, an outlier for teaching. But thanks to COVID, it became the normalcy for teaching. And so our world has shifted. So my question is, based on these constructs, how do we support this space? What are your thoughts? Amanda, your mic is open. Okay.
Yeah, I'm not, I mean, there's plenty of things to do in preparing teachers for use of using technologies in their classrooms, right? I'm not sure what angle you're thinking of going with.
It's
So
open because our spaces are so different. So whatever makes sense for your perspective, feel free to share your thinking.
yeah, sharing the best practices with each other, like an exploration of different tools and how they've used it or might try it. Pairing them with instructional designers at your institution to present at conferences about it, perhaps.
It's a
Providing-
tough question, right?
I wonder too if so sometimes there's workshops or conversations, presentations that occur at our institutions in higher ed that although they're for faculty, students could be welcome to those.
Okay.
You know,
Making it
I think to, oh,
go, feel free, continue.
Oh, thank you. Yeah, I think also just having a situation where you are giving more feedback and understanding of what these digital learning programs are doing, technology, how to embed that into, like, for in particular a math classroom, you know, that's my thing. So my thing is, like, for instance, with Big Ideas Learning, we would say, okay, do the teachers understand how to use this? But not only just kind of the surface level, really embed it into instruction, and how do we incorporate our digital platform with the mathematical practices? Are we sure that they understand that? Is it seamless? Okay. And then we would follow up. So I think also having follow-ups throughout the year to make sure that these teachers are also progressing, not just the students, but also the teachers. Because I find that the breakdown has been, we give the training at the beginning of the year, we check in maybe 5 years later, instead of really kind of building that relationship and saying that we're working partners. This is a trusted partnership. We want to make sure that your students can be successful, and also that you as the teacher can be successful and not feel like this is one more thing that we're throwing at you. You know, and that's what I think right now is there's this huge culture of within educators of, oh, there's one more thing they piled on us. Here's another program we have to learn. Here's another digital component, and our students are still struggling. The students aren't coming to class, and I don't even know how to use this program. So I'm just going to go back to what I know, which is chalkboard, and, you know, I'll use worksheets, and I'll go to teacher tube and teachers pay teachers, because that's what I'm comfortable with and that's what I know, instead of really trying to get to know that program, because I feel that we don't spend enough time with teachers at the beginning to make sure that they understand how this is incorporated with mathematical practices and how to really kind of implement that program throughout the school year. So I think spending more time with educators is key.
Wow.
Thank you for,
Oh,
if I could,
sorry.
yeah, thank you for sharing that, Dr. White. And what came to mind to me as you were saying that is like expressing to teachers, candidates, that it's okay to master, you know, just a couple of, you know, technological tools, because like Dr. Sears said earlier, there's so many to choose from. And trying to master them all is just going to be close to impossible. And so trying to become an expert in just a few and maybe adding them as the year goes on, I think will be helpful, as opposed to like trying to master everything.
I'm sorry, go ahead.
I was going to also highlight the technology integration framework, because that is one of the challenges, as Dr. White highlighted. You know, they're not comfortable, so they do drill and practice. So although the participation level, so it's very entry level, where a teacher uses technology to deliver the curriculum, but it's not, I'm thinking about the extent it's active, or we talk about collaborative or constructive, authentic. But it's the same way we think about this notion as to the characteristics of the learning environment, we have to also think about the level of integration, from entry level to adoption to adaption to infusion and transformation. But it goes back to the fundamental role the technology is being used for. Because like when you think about it, like, you know, notion of using technology to facilitate, is it being to promote cycles of proof? Is it considering presenting and connecting multiple representation? Is it supporting case-based reasoning? Or is it really serving as a 2D for mathematics? So that comes out of Cullen's work in 2020. And so when you think about it being used as a promoting cycles of proof, using technology to explore mathematical topics, or think about generating conjectures or testing and revising the conjectures, and ultimately helping students prove, that can be a different way. For example, like how do you use it to emphasize proving? While in other cases, you can actually use it to reflect on different forms of representation and making connections across representation. And so you use technology to display at least two representation for a particular mathematical object or idea. Likewise, you could use it to support a case-based reasoning. So we think about generating or organizing ideas and analyzing them using a particular technology. While in other cases, it could be used as a 2D. So we have IXL, we have many programs. I saw Brilliant.org, I mean, My Math Lab, Pearson products, Cengage products. They all could be used in that capacity. And so really thinking about what is the role itself that we want to integrate the technology, it's going to have to be critical as to how we envision it. And as we think about, as we move from just mathematical thinking to intersecting computational thinking, that also has to be considered as well, because in this era of digital coding and stuff, like I've seen last time, a person, oh, I'm teaching the child to code, but I'm saying, you're teaching the code, but how are you making a connection to what is coding? How is it a mathematical language? How are we understanding a system? You know, A informs B, B informs C. And so that's why you could have an inconsistent code, on which why we'd see an error. And having them explain and make that connection. Because from that perspective of thinking about that intersection of computational thinking and mathematical thinking, the things that are always stable are going to be problem solving, modeling, data analysis, statistics, and probability. And that came of Shoot All work in 2017. And so when we think about this space, I think we're now challenged as educators to move beyond just saying we want to teach digitally, but teach purposefully in a digital world. So we're really thinking about our language and our centering of that language to move the field forward. Because as I think about, like I said, Florida Distance Learning Association, we have come a long way. But the question is, how do we move forward in the technological era in which we're living? I mean, we now have Space Force. So that tells me by definition, we're going to have the students have to understand quantum physics or quantum analysis. But what does that mean for high school mathematics? What applications are going to be needed for students to conceptualize this notion as to, the thrust to get us into space, to be, how do we teach that? Would calculus now be taught in 8th grade? Because Algebra 1 in the 1600s was an indicator to get into Harvard. And now in 2022, Algebra 1 is being taught in 8th grade. So as we move forward, well, to what extent do we have to change the way our math is structured to ensure our students are responsive to the world in which they live? So this is an opportunity for us to reflect on the implication of technology, not on mathematics, just teaching and learning, but also on mathematics, curriculum, and assessment as well.
Thank you so much, Dr. Sears. And just to come alongside the idea of using technology intentionally and strategically as we model it for our students in our programs, I think is something that we've tried to do as well. So
I think we had maybe a couple more people that wanted to share out, but we just have 2 more minutes. So if there's any other comments or responses to this question, we welcome them.
All right, so thank you all for your time. I guess we're good on time because the next session starts at 10:30. So thank you all, and I trust you all have a wonderful day. And for those at AMTE, have fun in NOLA for both of us.
Thanks, guys. Excellent
Thank
job.
you, everybody.
Thank
Good seeing you.
Yes, and now the awards panel. So stick around. I'll be back in 2 minutes.
Is it the same Zoom?
It's the same Zoom. Yeah, it's the same Zoom.
Oh, okay.
That was an awesome presentation. So thank you very much. Award session will start momentarily.